just to recap electron configurations, I thought I would make this short video. So when we're looking at the periodic table, keep in mind that it's this section, okay, this rectangle, and we bring helium over here. This is going to be our S section. The P section is over here. D is this section. And then the series that were brought down, I'll use orange down here. This corresponds to this F sublevel. So S, P, D, and F. Remember, S is only able to hold 2 electrons, and I'll make a note of this over here. So S can hold 2 electrons, P can hold a total of 6, D can hold 10, and F can hold 14. So when we start doing an electron configuration, you are always going to start with back at the beginning with hydrogen, and we go in order from lowest energy orbital to highest energy orbital. We always follow the same pattern. So 1s, 2s, 2p, 3s, 3p, 4s. Remember, after 4s, right here, we actually have 3d. So the D sublevel is always one row behind where it appears to be. So it looks like it's here on this 4th row, but actually it's the 3rd energy level. Then we have 4p, 5s, this would be 4d, 5p, 6s, and then this is where we end up dropping down and we get to 4f. So F is 2 back from where it appears to be. If we're in the 6th energy level, it's actually 4f. That'd be 4f, and then we have 5d, 6p, and so on. I'm just going to walk you through the first, or about 8 elements from the beginning, 2 rows, and then I'll do 3 others, S, E, C, O, and P, D, just to show you some that are a little bit longer. So for hydrogen, remember we always start up here, and we start at hydrogen, which is located in energy level 1, in the S section, and there's only 1 electron. So that's 1, this would be 2 electrons. So then the only difference here is He is still in the 1st energy level in the S subshell, but there's 2 electrons. I can't place any more electrons in the S sublevel. It can only hold 2 maximum. Since that is the case, I'm now going to have to go 1s and then move to the next orbital, which would be 2s. So I've run out of room in the 1st orbital. So this first one would be 1s, and I know that can hold 2 electrons, but I'm right here at lithium. So now we're in row 2 in the S shell, and I still have 1 electron to place there. For beryllium, it's going to be very similar, 1s2, so that's where beryllium's first 2 electrons will go, and then the second 2 will go to s2. Again, S can only hold 2 electrons, so I can't put any more in 2s, which means we have to go from 2s for the next element over here to 2p. So continuing on, we start over at the beginning with hydrogen. 1s2. I'm going to completely fill the 1s shell, and I'm going to fill the 2s shell. 2s2. And boron, we have 1 additional electron, so now we're in 2p, and there's only 1 electron there. For oxygen, so we're skipping carbon and nitrogen, we're going right here. We're starting over at the beginning, 1s2, 2s2, and then oxygen is 1, 2, 3, 4 over in this 2p sublevel, which means there are 4 electrons that still need to be placed. So that would be 2p4. Okay, for F, that's going to be, starting over again, 1s2, 2s2, 2p. Okay, that would be 1, 2, 3, 4, 5. So that's going to be 2p5. And then for neon, it would be 1s2, 2s2, and then 2p. Okay, so 2p, 1, 2, 3, 4, 5, 6. 2p6. Now, we're going to do this for Se, which is a little bit farther down the periodic table. So Se is here. I always have to start with hydrogen, so I'm going to start back over. 1s2, 2s2. And remember, we are following the order of the periodic table. So we start up here with 1s, 1 and 2, 2s. We move into 2p. So that would be 2p, and I'm going to completely fill the 2p shell because I have to reach selenium, which contains 34 electrons. After 2p, so here was 2p, we just go to the next row of the periodic table. Here we are. We're in 3s, and then we're going to end up in 3p. So 3s2, 3p6. We're still following the order. Here's 3p6. Now we're in 4s. We go to 4s2, so we've completely filled that shell. And now we've gotten to our row that doesn't quite follow our order. So remember, this is not 4D, this is 3D. So we're going to write 3D, and let's count over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's going to be 3D10. After 3D10, we're here, and this is the row that selenium is located in. That is 4p. And let's see how many we need to count over in 4p. 1, 2, 3, 4. So that's going to be 4p4. All right, let's do the same for cobalt. Okay, cobalt is here. So cobalt, starting over at the beginning, 1s2, 2s2, 2p6, 3s2, 3p6. So we've just been increasing in order. Okay, we are now 1s2, 2s2, 2p6, 3s2, 3p6. That has brought us here to 4s2. Remember, after 4s2, after this, we move into 3d. And this is where cobalt is located, so let's just count over. 1, 2, 3, 4, 5, 6, 7. That would be 3d7. And then finally, we're going to try one more that is even further down the periodic table. We are going to go all the way to palladium. All right, so starting at the beginning, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. And up until 4s2, everything has been what we expect for the order. S and P, and then S and P. Remember, after 4s2, we come here to 3d. So 3d, and we have to go all the way to the end of this row and then keep going because palladium is right here. Okay, so that's going to be 3d10. After 3d, we're at 4p, and we're going to have to go to the end of that row. So we're here at krypton. Okay, now we're right here in 5s, and we're going to have to keep moving past 5s. And now we are in the same row as palladium. So this is 4d, and let's see how far we have to go over. 1, 2, 3, 4, 5, 6, 7, 8. So that is going to be that's going to be 4d8 for the electron configurations. I hope this is a good refresher and that it helps electron configurations make a little bit more sense, but I will be ready to answer your questions on Tuesday morning.